We can, dare I say it, change the world. Take it, Dr. B.
Hello, I'm Bruce Betts, Director of Projects for the Planetary Society. Welcome to our live PlanetCast for the close approach of Asteroid 2012 DA14 that is approaching closer than geosynchronous satellites. And the closest approach will be about 11:24, just a few minutes now.
11:24 Pacific.
Pacific time, yes, that would be 1924 UT for those of you playing the Universal game. This asteroid is about 45 meters in diameter. It will not hit. However, in a cosmic coincidence, there was a fireball, possibly the largest impact of a meteoroid since the Tunguska event in 1908, and also so coincidental, hitting before the asteroid flyby today, and coincidental based on the area of Russia, that it also hit in Russia, just like Tunguska. I turned over to Bill Nye, our CEO, for some witty banter.
Yeah. So welcome, everyone. This is something the Planetary Society has been working on for a long time. And Dr. Betts, to his credit, for the last 15 going on 16 years, has managed to find people around the world who are worthy, amateur astronomers, who are especially good at finding these objects. Especially good. These objects are fast moving and they're relatively close to the Earth. So by finding them, we're doing something that no one else in the world is doing. Now, NASA, here in the US, does do quite a survey for the larger objects, right? But these small ones, by the word small, big as a, what, 7-story building, they're unusual. We haven't logged enough of them. So we've only found about 1% of them. And that leaves 99%.
There's a lot of stuff out there. We found
do what it did today.
Found a lot more of the really big ones, but these small ones, most small being a relative term, like this 45-meter half football field size asteroid flying by in a few minutes, we, as you say, a very small percentage have been found. Lots more to be done. Let me just do a quick mention of other things we're going to have on the show today. We are going to take a tour that we recorded this morning, Pacific time, evening Spain time, of La Sagra Observatory in Spain, where they discovered 2012 DA14, thanks to a Planetary Society grant.
So if you're a member, thank you.
Yes.
You could be saving the world, and I'm not exaggerating. I mean, you really could be.
And if you're not a member or donor, I'll go ahead and shamelessly throw in that you can find donate links on both the YouTube page and the Planetary Society page that will help you, help us support the astronomers who do these kind of programs. And they do a lot of follow-ups. So there's a little bit of discovery, particularly groups like La Sagra that have come up with very clever methods using fast readout cameras. But there's also a lot of follow-up observations. So even when the professional surveys find objects, it doesn't do you much good to know an object's there if you don't know what its orbit is. To get its orbit, you need lots and lots of measurements, and that's where these hardcore, awesome amateur observers, as well as professionals, come in finding, tracking, characterizing. So check out planetary.org and check out the donation page if you feel like saving the world. But we will also, so we'll do our tour of La Sagra Observatory. We'll also be giving you information about 2012 DA14. We will also be giving information and talking about the fireball in Russia that occurred only a few hours ago, and discuss that as well. And we'll be having some fun. 4 minutes till closest approach. Not that that's, other than closest approach, a magic time, but this object's coming by about 25,000 kilometers per hour when it comes flying by.
You can cover some space at that speed.
You cover space, and because it's only a matter of tens of thousands of kilometers away, it's actually doing a pretty good movement across the sky, which makes it a very hard object to see, because astronomers are not used to looking for things that are moving across the sky at about 1 lunar diameter per minute, or 2 actually.
Especially dim objects. That makes it all
I should clarify, in terms of visibility, we will look at some astronomy feeds in a little while. In terms of visibility, this is passing in the eastern hemisphere. It's over, the closest approach is roughly over Indonesia. And after we get past closest approach time, we'll also show some videos that'll make that clearer. And even from there, it's not a naked eye object. We will also, you can see it, but it's a tricky object with binoculars with telescopes. For those in the Western Hemisphere, like we are over in the Americas, it's on the other side of the planet, but there will be a lot of observing going on in a few hours.
As the world turns, yeah.
That'd be a good name for a show.
I don't know if it would sell. But as the world turns, we will come to where we can see this thing, which is pretty distant, going from south to north, as we humans reckon. And it's really a warning. Everybody should think about this as something that could go wrong, something that could happen here. So closest approach is in 3 minutes.
In 3 minutes. And then right after closest approach, we will connect with Jaime Nomen, one of the discoverers from the Sagra Observatory, and talk to him live via Skype. So it's going to be good.
Are people sending in their questions? It looks like there are. There are. Here's
okay, so we've got questions coming in. You can submit them over the YouTube comments channel. There will be a way, can they use someone tracking the email or not? So you can also email planetcast@planetary.org with your questions. So let's see, what do we got? Where exactly is the asteroid flying over? Well, I finally got to that. It is, although I did not mention, it's going from the southern hemisphere to the northern hemisphere. So this asteroid, if you have the orbit of the Earth, this asteroid's orbit is inclined. It's inclined about 10 degrees, but we also have the Earth with its tilt. When you combine all this together, the asteroid is flying from the southern hemisphere to the northern hemisphere. So right closest approach, as I say, is right about over Indonesia. And that's about where it is right now. Let's see, do we have...
Yeah, so somebody asked about 15 minutes difference. So I spoke with Ed Liu, who was a former astronaut. I guess he still is an astronaut, and he now works on trying to build a privately funded telescope to look for asteroids. But he talked about this, and if it looks to me, I ran the same numbers, it's 15.5 minutes, something like that. If the Earth were 15 minutes sooner, or the asteroid were 15 minutes sooner, or both of them were 7.5 minutes sooner, there would have been a collision. And this wouldn't have been like the thing in Russia with the spectacular bright lights in the sky and then the spectacular blowing out of windows and doors on the ground. It would be a city killer. I mean, it would take out Manhattan, could just destroy it. Paris, destroy it. Sydney, Australia, gone, just like that.
Or if it hit in the ocean, particularly near a coastal area, you could create a pretty serious tsunami.
A tsunami that would do the same thing, except maybe more than one city at a time.
Right.
And so this is something that we at the Planetary Society are very concerned about. It sounds like science fiction, but it's the real deal. How much, what do we have in moments to...
Mere moment. Wait,
there it is.
There it is, the alarm. Congratulations, everyone. It's 2012, DA14, closest approach right now. But stay tuned. We have all our
Did you feel it? No, you
content.
don't feel a thing. But if we were in the Ural Mountains last night or yesterday afternoon, they felt a similar unrelated object. I like to say unrelated but related. Same primordial stuff, perhaps, but in a different orbit around the sun, and it crossed the Earth's path. A lot of people have asked about, will the Earth's gravity affect the orbit of this asteroid 2012 DA14 next time? And the answer is, yeah, it's going to shorten or tighten its orbit up, right?
Right. So we'll go this past, what's happening right now, the Earth's gravity is bending that orbit, and it'll be an orbit very similar to Earth's. It had a period of 368 days, a year of 368 days.
These are
after
Earth days.
the pass, yes, thank you. After the pass, it will have an orbit of 317 Earth days. So it's significantly altered by this close a pass to Earth.
Those of you unfamiliar with it, this is the symbol for tighten the orbit.
Yeah, tighten the orbit.
So
this is the symbol for close encounter or flyby.
It really is remarkable that we are the first generation.
Oh my God, I think I hear it.
Yeah. And no cell phone interference, you guys. No weather satellites. I heard from a very good source that there may be a spent military rocket fuselage out there that it's going to miss by about 100 kilometers, which is an hour of freeway driving. but it's a few moments at 25, I guess in English units, 25,000 miles an hour, right?
Right.
So,
so
it really is, there's just a lot of space in space.
Okay, we have got Jaime Nomen on. We'll get to lots of questions.
Good.
We'll show lots of video. We'll take a look at observations that have been occurring. But right now, we've got, right after the moment of closest approach, Jaime Nomen, the astronomer, dental surgeon by day, awesome astronomer by night. He is at La Sagra Observatory in Spain, and we will be talking to him live. Are we hooked up?
Yes. Here we are.
Okay, Jaime. Hi, Jaime. Welcome, and thank you so much for joining us. So we've got a live webcast audience. Congratulations, I guess. I don't know what the right thing to say is, on the closest approach just happening.
Can you hear you?
Can you hear me okay?
Matt, Bruce?
Yes.
Hello?
Hi.
Hi. Jaime, can you hear them?
Yes, okay, fine. I can hear you.
Are you preparing for your observations in a couple hours? Are you ready to observe the asteroid?
Yes, are you talking with me? Because it's cutting the conversation.
Yes, I'm talking with you. I'm going to lean over closer to where I'm talking with Jaime. Can you hear me now okay, Jaime?
Yes, well, Bruce, I can hear you.
Are you ready for your observations of the asteroid?
Yes, we are waiting. It's still under the horizon. I think just now it's crossing the closest to the Earth. I think
yes.
1 year ago. But here we have it still under 20 degrees or so. Until 21 hours UT, we can't start. But the telescope is ready to start to stream. Yes.
Can you tell us a little bit about your camera system and how you discovered this asteroid a year ago?
Yes, why not? The camera, in the past we were working with the same telescopes, but with other cameras that the problem had a very slow readout. The speed of the readout of the images is essential when we want to track very fast moving objects. So thanks to the Planetary Society and the grant, we were able to upgrade our CCD camera with our old CCD camera by one that is much faster. And this allows us to discover such fast objects as 2012 DA14 last year.
That's great. It was thanks again. I'll mention one more time to Planetary Society grant and our members and donors enabling us to be able to provide that camera for you to use this amazing technique. I should point out La Sagra Observatory is amazing in terms of its discovery rate as well as follow-up. How many near-Earth asteroids have you discovered in the last 2 years or so?
Okay, more or less 67 near-Earth objects. The last was last week. And 7 comets, but if we talk about main belted asteroids, around 6,500.
Wow, that's amazing. And we will show the audience the video that we did this morning of you, the tour of the observatory, and I think people will be very interested in that. I don't want to hold you up too long. I know you've got a lot to do. I will remind for those who are joining us, this is Jaime Nomen, live from Spain at the La Sagra Observatory, where he and his colleagues made the discovery of this asteroid a year ago. Anything else you'd like to add or share with us, or any questions you have, Bill?
Well, just fantastic job. Just want to thank you and congratulate you again. And we are working to remind everyone of the importance of your work. Remind everyone of this could end the world with something like this. So really appreciate your diligence and your understanding of the equipment you needed so that we could provide it for you.
Thank you very much. We are a team very motivated and enjoying this work. So, and thanks for your help. Both can contribute to work in such field as we do. currently. Thank you.
So Jaime, I know it's on our planetary radio interview from a couple weeks ago that people can find online at planetary.org. But where were you when you discovered 2012 DA14?
Okay, I was, better don't tell about that, but because I was on a sailboat during the night. But, okay, this means how is our work, because, okay, it has no sense to check discoveries maybe 2 or 3 days later than they were spotted in the sky, because then maybe it's too late. So all the team, we are working all the day, working or in holidays or everywhere. We work with laptops, and because we never know the moment we can discover an asteroid. So in this case, it was in a sailboat, but could be in a train or anywhere. So usually we make some shifts during the night that any of us always is ready, checking the discoveries. And that night was my shift, and I was in a sailboat, certainly. And that, okay, was, yes, a nice or curious situation, right.
Jaime, we got a question that came in by email. Is it possible, in your opinion, that there is another object or another set of objects following along DA14?
Okay, if you tell this because this event we have suffered today in Russia, okay, this is not my field, but my opinion, watching the videos in which I see that the fireball was coming from north to south, and considering that 2012 the DA14 is coming from south to north, possibly the orbit would not be the same, so probably has nothing to do. But this is incredible. This is a really, really incredible coincidence that during many, many years never happened that, and just the day that the asteroid that is coming closest to the Earth is happening something like that. So it's really, I can't believe it. This morning when I read this and even see videos and how the blast was, and couldn't believe it. I was thinking that I was dreaming.
It was fantastic. We all hope that it is what we call a teachable moment for everyone in the world, that this is potentially a very serious situation. And although a lot of people were injured in Russia, and I'm sorry about that, heart goes out to you, it could have been a lot worse. So let's keep watching the skies, as the saying goes.
Well, great. Thank you so much again for those joining us now. This is Jaime Nomen from the Sagra Observatory, co-discoverer of 2012 DA14, and he's joining us live, and I know you've got work to go back to, Jaime. So thank you very, very much for joining us, and people will see the video tour of the observatory shortly. Thank you.
Okay, thank you very much. Thank you very much to you, to everybody who is listening here, and bye-bye.
Bye-bye. Adios.
Adios.
Adios. Adios.
Adios. Okay, so thanks to Jaime. I think why don't we take... despite what we say, truly that was not caused by the asteroid or the fireball. Let's take a look at video animation of this asteroid. We'll be pulling that up in a minute. Yeah, this is from JPL, produced this, and let me turn the sound down. So here you get, I love this part at the top, not actual asteroid. So here you see compared to a football field.
It looks just like one.
So this is showing what it's doing right now and how far away it is at that closest approach, 70,200 miles. That ring is showing geosynchronous satellites. So things like satellite TV. The reason you can point your dish in one direction is those satellites orbiting at that height. Is it visible to the unaided eye? No. But here we see, so from the asteroid's perspective, see, notice that's Antarctica. It's coming from the southern hemisphere, obviously. Here's the flyover, roughly, in Southeast Asia. And then it moving away. And all of the course of that video is just a few hours. These are the discovery shots from the Sagra Observatory, from Jaime Nomen. And that's the moving object. Has an asteroid this size ever hit Earth? Yes, as we mentioned, the Tunguska impact, which occurred in Siberia, about I think 1,000 to 1,500 kilometers east of where last night's fireball was, well, our last night, occurred in Tunguska. And as we mentioned, it leveled thousands of square kilometers of forest from that blast. All right, we'll stop that with Don Yeomans from JPL talking. So that's
we got another question from the web. Oh no, this is from email. Does NASA actually have the ability to destroy something like this with lasers? And I will say to I don't see your name there, but you probably know who you are. Anyway, NASA does not have this capability. And wait, there's more. The people working on doing this job with lasers is the Planetary Society. If you're a member, you are working on this. If you're not a member, think about joining. Check out the donate button. But what we have is researchers at the University of Strathclyde in Scotland, and they shoot a laser at meteorite simulant rocks. And they look for the ejecta, the stuff that burns off, that ablates. And so our idea is to have a flotilla, a group, a network of small satellites that would have solar panels, soak up sunlight, use that electricity to pump lasers, beam the lasers at the asteroid. The ejecta would act like a jet or rocket motor to ever so slightly change the speed of the asteroid. That's the key. You might think, intuitively, you might think you want to push the asteroid north or south to get it, to keep it from hitting the Earth. But that turns out to be extraordinarily difficult. That is to say, you need a lot of energy, a lot of delta V, the change in velocity. But if you can ever so slightly speed it up or slow it down, then it will not cross the Earth's orbit when we are there. And so we're talking about a few millimeters a second. So this is why we want to identify these objects as soon as we can. So we're talking about decades in advance. So we can go out there with our laser bees, as we like to call them, because it's like a swarm of lasers, swarm of bees, and just give it a gentle nudge. Another idea you'll hear about is just to run into the thing with a rocket. Just make a big rocket and smack into it and change its speed. And then people talk about building a relatively massive spacecraft that would go out there, and its mutual gravity with the asteroid would give it the tug, like a tugboat, that it needs to change speed. But all this is only possible if we can find these things. If we can't find these things, it doesn't matter. We'll end up like the people in Russia yesterday afternoon. We'll just be surprised and things will go wrong. So everybody, this is why, frankly, we're tooting our own horn here. The Planetary Society funded astronomers in Sagra, Spain, who found these small, as big as a huge building, asteroid that's going to just miss us. But it's only about 1% of all the asteroids of about that size out there. So there's another 100,000 waiting for us. So everybody, thanks for your support. It's a teachable day, an exciting day, a scary day, and I hope in the course of human events, an important day.
Yeah, me too. We've got a lot of questions, but I think let's switch because we've given some intro about the 2012 DA14 asteroid flyby. We've mentioned the Russian the fireball meteoroid event. But it's really quite impressive. The latest estimate I saw from NASA was that this was a 15-meter diameter object, so third the size of the one flying by in terms of diameter, but a lot big, less
energy.
big. Thank you.
Smaller?
A lot less energy. Smaller. That would be the word I was looking for. A lot smaller than this other object, but still amazing video. Let's take a quick look at some video, just some of the things popping up on YouTube through amazing. This new kids' technology.
The electric computer machines that the kids are using?
Yeah, something like the iNet. So there we have,
That's a bolide is an old, I guess its word comes from Greek, and it means a meteor that happens in the daytime. So this is, a meteor, by the way, is by rule or definition something that makes a streak in the sky. So there's a meteoroid, that's out in space. When it makes a streak in the sky, that's a meteor, and when it if pieces of it land on the Earth, those become meteorites. And somebody asked me earlier, are there any meteorites? Has anybody found meteorites? And so far, none are reported, but you got to figure with something that big and that spectacular,
Yeah,
there's
I
going
saw
to be
they were
some.
starting to find some that also are reports, of course they keep changing, that they have a hole in the ice of a few meters across that may be there. But in any case, you had this object streaking across the sky, and you saw in that brief video the contrail, or what was left as it came through the lower atmosphere. But what was really impressive, and I'm not sure we got the sound out, but after our presentation, you can check these out on the internet, and I will simulate it for you. But they're watching it, and usually most of these videos they're watching, and there's this weird smoke, like, oh wow, it's really neat.
But this
we're
one
having fun, and then ting, 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 ting. That's the sound of breaking glass.
Which apparently is how a lot of people got hurt.
Yeah, probably looking out windows at that amazing thing. So that's the shock wave. So as it comes through, just like an airplane that's gone supersonic has a shock wave built in front of it, well, here you have a much more energetic object with a lot of energy behind that shock wave, and it keeps going down to the surface, but it takes time. It's like thunder after lightning. It takes time to come down, and then that pressure wave hits, and that's what broke the glass and caused the injuries. And that's what, on a much larger scale, would happen with the larger type asteroid.
So it's not little pebbles or P's or BB's from the meteor, from the bolide, from the object. It's the pressure. And I've tried to impress, I guess that's a pun, tried to make this point with people today, that these things, you may have heard the expression, if you jump off the Golden Gate Bridge, even pointing your toes won't help you, because when you hit the water it'll be like concrete because you're going so fast. Well, in this case, these things are going at extraordinary speeds. 33,000 kilometers a second, 25,000 miles an hour. They shatter when they hit the atmosphere. The atmosphere acts like the concrete, and the thing disintegrates. And then after that, it's made of some material that oxidizes. Maybe it's iron, maybe it's silicon. It combusts, it burns with the oxygen in the Earth's air, and you get this crazy vapor trail of smoke. Man, it was just spectacular.
It's really spectacular. We, for resources on all of this, go to planetary.org, Planetary Society
Your
website.
homepage.
And from there, you will find and can navigate to other things. Information about 2012 DA14. There's a link at the top with pretty picture, a link at the bottom with observatory. We've also got links to Emily Lakdawalla, our wonderful blogger, and here at the Planetary Society has assembled a whole bunch of video links, background links related to the Russian fireball, so you can check those out and go enjoy them yourselves. When we get a chance, let me check. Let's run another one of those videos just to show a little more information. And then let's show what we're getting about 2012 DA14 from observatories. But first, let's take a look at another one of these videos out of Russia. And this one's fascinating because this was a dashboard cam, and look, you can see it actually coming in, breaking apart, heating up, and then dissipating, going across the air. So fast-moving objects, impressive amount of energy. Again, apparently the first
Captured on video. So apparently there's a million dashboard cams in Russia.
Wow.
To combat police corruption.
Well, this is not the only one. There are others I saw. It's the nice side of having all sorts of cameras and videos.
When I worked in television, and you walk through the newsroom, worked in local television stations. Yeah, you walk through the newsroom. The joke was, well, it's like trying to photograph a car wreck, because you can't predict where it would be if you have a news crew with one camera. Well, now when you have 7 billion people on Earth and a substantial fraction of them have cameras, you can actually photograph car wreck. You can actually tape or record a bolide entering the atmosphere. What a remarkable time.
It really is an amazing era. I mean, 1908, Tunguska took out a forest, and people still
didn't photograph it for a year and a half.
Yeah, still didn't know about it. They could see evidence, by the way. It affected sunsets, sunrises. They can see lights at night.
Changed
sunrises.
by the sun.
But there was extra, changed by the dust in the atmosphere, places in England and Western Europe.
So it's an opportunity, everybody. It's an opportunity for the governments of the world, the scientists of the world, the astronomers of the world, and may I just throw in the engineers of the world, to get together and save the planet from save the part of the planet that we like, from these objects. So it's an extraordinary time. What is it, 2013, February 15th, day after Valentine's Day, 2013, a day that may live in history, as a respected day where humans got together and started to address this problem, these things.
You say, okay, we're going to go to...
oh, yeah, here's a classic question, Bruce.
Hang on.
Oh, yeah, sorry.
We got video going out. That's okay. You can't see the monitor. So this is video of...
Roger this.
Or pseudo-video taken of Asteroid 2012 DA14 taken from Gingan Observatory in Australia. They kind of run it back and forth.
So Australia
on a loop, so it's nearly live, but not quite.
Not that far from Indonesia, where it's closest to Peru.
Right, and so what we see going across the screen is the asteroid. You can see some fixed stars in the background. The asteroid has some dimension to it. It's like a little bar, but that is not because that's the shape, but instead it's just moving that much during the exposure that they've taken.
It's the blur.
So you can see the camera is fixed on the stars because the stars in the shot stay in a fixed location. So that's the type of view we're getting from observatories elsewhere.
There's a classic question.
Okay, now go for the classic question.
Yeah, well, let's see, you scrolled just a little past it. Could it change the Earth's orbit, or does the Earth change the orbit? And it does. The Earth's changing the orbit of the asteroid a little bit. Then could a meteorite change the tides or weather, etc., on Earth? That's a classic question. This one cannot. It's just too small. I mean, it would do extraordinary damage for us humans when it hit the atmosphere, but it's not enough to affect the ocean. It's a very good question, though. Could it hit something next time around? That's another question. And yeah, it could. Now, next time around, I've heard different reports on next time around. 21-something, 2080.
No, it comes back...
every year.
Yeah, almost every year. That'll shift because it's going to this shorter period. But it has frequent encounters, so to speak, but they're all going to be really far away for many decades, certainly compared to this. There's still non-zero chances of it hitting very late in this century or early next century, but to be honest, after they get the radar and telescopic data from this pass, they probably will be able to rule that out. They'll be able to refine the orbit more precisely from all the data that's being gathered now. So nothing to worry about from 2012 DA14 for decades, and probably not thereafter for a while. It's the other objects that we haven't found that we have to worry about. All right, I'm trying to scroll while we're doing this. So
yeah, since there's a lot of water in asteroids, can't you just heat it up enough for the water to evaporate and change the mass? This is talking about when we're in deep space and we'd shoot it with a laser. Yeah, yeah. If we could vaporize water ice on a cometary body that was coming at the Earth, we could change its velocity. Yeah,
bring it on. There isn't.
Great question.
There still isn't enough on an asteroid to be able to take. Or there are just other ways that would be more efficient
but if you
even ablating the rock itself, like with lasers or with nuclear weapons, which is not a preferred solution, but does get you the job done a lot faster.
So imagine that, everybody. Imagine that. Suppose the thing, we discovered it, pick a number, 7 years out instead of 20 years out. 7 years. We only got 7 years. Only got 7 years to do something about it. Then we got to launch a rocket and set off a nuclear device near it to disturb its velocity enough so it would miss the Earth. Okay, who's going to take responsibility for that? Launching a nuclear weapon. I mean, what about the countries of the world who don't trust each other? Who's going to take responsibility for saying, oh no, we got it, trust us, we're going to set off a nuclear weapon? No, we're not pointing it at you. No, it's all fine. So these are great questions. Yes, it's a wonderful rocket science engineering problem, and I love that about it. But it's also a problem, a much more difficult problem, I think, is international relations. So everybody out there, everybody's going to have a role in this when we find the one with our name on it.
Right. So this is, yeah, indeed, you have several steps to this process of the problem of asteroid threat, starting with finding objects, figuring out what to do about them if you find them, and then the political issues, which are very non-trivial, because you say some involve nuclear weapons. Even if you don't use that, then the target point moves across the Earth. As you divert an asteroid, it changes from one place to another and may move from London to Paris to Moscow, and someone's going to be upset.
Whose fault is that? Yeah.
Right.
And here's a classic right there is, do we have the technology to do this? How long would it take to develop it? And the answer is we kind of do.
We kind of do. There are no techniques that are well considered or developed. There are a lot of different ways you can do this. So some things like the so-called gravity tractor, where you take a spacecraft and you actually use the minute gravity tug of the spacecraft to pull it. The asteroid, that takes, of course, decades, and will only work with smaller objects. You can use things like nuclear weapons that have their own issues, and the nuclear weapons are understood, but how they would interact with a rock in space, not so understood.
You don't want the rock to break up and then have a shower of rocks.
We don't like that.
Yeah.
And kinetic impactors, where you slam into it with something, and then laser beams, which you mentioned, that we're looking into. Again, uncertain how effective it'll be. That's why we're doing the experimentation now and trying to figure it out. We would be hard-pressed if we discovered one now, particularly with fewer than a few years warning, to do something, and those techniques are being developed. But the first priority key is to figure out where these objects are.
That's right. Where are they? And then another science fiction problem, if you like to ponder this. Every asteroid that we know of is tumbling, has a little rotation. So you can't go up there with something very easily and land on it, because then it's going to be moving. And so all the schemes that we are pondering involve not having to attach to it. With that said, there is another proposal that's drifting around where people want to capture an asteroid with a net kind of thing and drag it between the Earth and the Moon just to learn more about changing the paths of asteroids. It's an extraordinary idea, but
not one of the techniques that's
not one of the techniques
considered for one of these larger objects. Yeah. Although that is related to our another question. I should mention that last question when I scrolled down, realized it was from Alex in Pittsburgh. Two questions now. One, is it theoretically possible to build a net to catch such a meteor, say, strung between two satellites? People have toyed with the net catch idea. It's usually viewed as too complicated, mostly because of what you mentioned. They're spinning. So what do? You put a net around this massive spinning object, and your spacecraft go bye-bye. But
if you had it worked out,
it's a possibility.
Where you'd let it wrap around the axle, if I can use that term, and then squirt a little rocket thruster to change the velocity just slightly. I mean, it's just cool, isn't it? I mean, the world could end, and that's traumatic. And yes, we haven't even started to log over 100,000 of these things. We don't know where they are exactly. Yes, that's interesting. I mean, that's of deep concern. But what's fun to think about is what you would do. To me, as an engineer, it's just fun. Okay, we're going to get a net. We're going to get spacecraft. We're going to go out there and wrap it up. No, we're going to make a gravity track. No, we're going to laze it and make it evaporate. It's just cool. It's science fiction, but it's real. And I hope that today drives home for everybody the importance of this. I mean, we are the first generation to do anything about it. The ancient dinosaurs apparently they didn't do anything about it. They didn't take any meetings. They didn't have a space program. And then what happened to them? Look at that. So it's really something to think about. I see somebody asked me, where do I get the bow tie? This particular bow tie, I'm certain I bought from a small company, which I'm very fond of, Astronomy 2 Go. And it was a straight tie, and I had it made into a bow tie by a company in Vermont, BEAU, Bow Ties of Vermont. And yes, I have an organization, a company who has approached me about having a Bill Nye line of bow ties. Yes, I am working on that. It's funny, I got 3 emails about it just sitting here. But right now we're talking asteroids. That's a thank you. Thank you. They accumulate. The bow ties accumulate. That's all I can tell you. I do. It's a thing now. I can't stop. You have another question there, Dr. B?
What pieces of the asteroid break off? I'm sorry, I can't read. Will pieces of the asteroid break off due to the gravitational pull of the Earth? And that's from Tom Marine, a teacher at Carl Thorpe School. No, they won't. But if you did asteroids, it does bring up an interesting point, though. Asteroids, one of the challenges in figuring out what to do about them is asteroids come in all sorts of flavors of their structure, ranging from iron, nickel, solid metal to light fluff balls with just loosely attached material. That's a light, yeah.
And
they
held
just
together,
like that.
held together
by
their
Bill Nye,
own,
by a bow tie.
oh, held together by their own very slight gravity, very small pull of gravity. And so what you bring up is quite reasonable. People talk about this so-called gravitational stress, where it starts to get near a relatively massive object like the Earth, and it pulls that conglomerate apart. It's a very good question, and this is why we want to study asteroids more, to understand what variety we'll be dealing with when we find one on a collision course with us again.
Yeah, so in this case, it should stay together. Let's take one more question, then we're going to go back to the Russia videos with sound, and then we're going to show you a tour of the observatory where things were discovered.
When is the next large asteroid expected to approach or impact the Earth?
And that's from Ben Soames and his KCA 7th and 8th
7th
grade
and 8th
class,
grade
who's
class.
watching right now.
Greetings, greetings. Thanks for watching. We don't know. Okay, so Tunguska was in 1908, June 30th. What is today? February 15th, 2013. So that's about a century. All right, so we can certainly expect one in the next century, but here's the thing about, this is what is hard for a lot of people to understand. This is a math thing, my friends. The probability of something happening is not necessarily the same as the effects of something happening. Like the probability of a plane crash is somewhat less than 1 in a million. You could fly for 1 million plane rides and never get in a plane crash, right? You could fly 10 million. But if you're on that one flight with that one plane crash, the effects are huge. And this is when people try to figure out what we call risk, the probability of something going wrong, this is a really hard thing for most of it. It's a math thing. So the best thing to do is to mitigate or deflect or change the course of as many asteroids that look like trouble as you can. So that's a great question. Yeah. And you guys in 7th and 8th grade, when you come of age as engineers, this is exactly the kind of problem you're going to have to think about. And if you're taking algebra right now, let me just say categorically, algebra is the key. And yes, it was hard for me and Dr. Bruce, as well. I presume it was hard for you. You have to do it over and over.
Oh, yeah.
You have to do it over and over. I'm sorry, man, man. You have to practice.
Practice.
All of this that we're talking about today, the course of it, the mass of it, how much damage it would do, how many are there, when's the next one, it's all math.
It's all math, and it's amazing how it actually works to predict stuff.
Predicts the
future. Just like you hope it does. Let me add just one thing. In terms of impact, we have no idea. There's nothing predicted other than very, very low probabilities. There will be a big flyby in 2029. The asteroid Apophis that is about 270 meters, so say 3 football fields in diameter, much bigger, 6 times longer than this asteroid, will fly by, again, about this kind of distance and will be even more visible. There are also other predictions of flybys that are going to occur, out beyond the moon, lunar diameter, things like that. There's a JPL website called NEO, near-earth-object.jpl.nasa.gov. that is pretty complicated, but if you want to get in there and dig into the predictions, they have predictions of all the closest approaches that are coming up. It's just that none are predicted at all of this size at this distance at this moment, except for Apophis.
Can you compare Apophis and 2012 DA14 to Meteor Crater, Arizona?
Yeah, so Meteor Crater, Arizona, best preserved crater on the planet, about a kilometer across. So
it's a little bigger than that. If you've never been, I recommend it. It's near Flagstaff.
It's big and impressive. That was probably formed by an object that was not that much bigger than 2012 DA14, but was one of the 4 or 5% that are made of iron nickel, and so therefore do more damage because more survive through the atmosphere to make the impact. You get up to an apophyse impactor, and whether it's rocky or iron, you're going to have damage beyond the scale of a meteor crater. That's regional destruction. So the one flying by now, city-scale destruction. That the Apophis is regional scale
multiple counties
destruction. You get to kilometers, then you're species-ending destruction, like 65 million years ago with the dinosaurs. All right, let's take a look at a couple videos, and then we'll come back and take more questions. So first, we've got the sound hooked up now for the videos from Russia, and so you might hear something besides us predicting, demonstrating. Here we go. Yeah, that's a lot more impressive. Well, not than you were.
We weren't there.
Oh, and listen to all the car alarms everywhere. It's quite the...
It shook everything.
Yeah, so very, very impressive.
We dodged a small bullet. Look at these questions. These are fantastic.
We do, but I really want to get
the
observatory tour.
Oh, yes.
We will be doing in a moment. What the heck? Let's take one question. Right now, does it give you guys a sense of joy and humanity that amateur hobbyists are capturing and contributing to such events? Oh my gosh, yes.
Yes, 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 yes. So understand, everybody, I had Carl Sagan for astronomy. Dr. Betts had Bruce Murray for astronomy, and these are two of the three guys that founded the Planetary Society, along with Lou Friedman, our previous executive director. And they founded it for just this reason. People around the world are so passionate about space, and many of our members are not only passionate about it, they are deeply involved in understanding it. And so what's happened, for historical reasons, NASA, the world's largest space agency, has observed the very large, or what are relatively large, asteroids and cataloged them. But for historical reasons, because it's neither human spaceflight nor is it science as such, cataloging all these smaller asteroids has sort of fallen through the humanity crack. And so what we want to do is get people around the world who are passionate about this. By the way, the term amateur astronomer in astronomy means something quite different from amateur ping pong player. It's somebody who's much more involved in the science. And so it is people like you, our members around the world, over 30,000 people who are concerned about humanity's future and so on, who help us fund these guys in Spain who found this thing. So, oh gosh, yes, is the answer.
Speaking of those guys in Spain, Bill, we're going to go back to Jaime Nomen, a little segment that he and I recorded this morning. So it was just as the sun was going down in Spain, and a tour of their facility. Again, amateur astronomers, a whole group of them. Jaime's a dental surgeon by day and does this by night. They've got the facility set up so they can do most of this robotically. They're up there for the encounters. Anyway, let's take a look at Jaime, and then we'll come back and take lots of questions.
Hi, I'm Bruce Betts, Director of Projects for the Planetary Society, and we've got a great opportunity right now. We are going to get a tour of La Sagra Observatory in Spain, where the asteroid 2012 DA14 was discovered about a year ago, and we're doing this just a very few hours before its close flyby of Earth, coming closer than geosynchronous satellites. And we've got Jaime Nomen at La Sagra Observatory, one of the discoverers. We've got him live over Skype video, and he is going to be walking around with his webcam and showing us their amazing facility. So welcome, Jaime, and thank you so much for joining us, particularly on such a very, very busy day.
Okay, thank you very much to you and to the Planetary Society. Okay, we will try to make the tour around, and I will explain our facilities.
Wonderful.
Okay, so then we will try to do it. Maybe somehow works, somehow fails, no? But this is, okay, I think I'm free with wires. Okay. More or less, this is the room, the observatory room of La Sagra. Here we have several computers. Some of them are taking control of the telescopes. Some others are for processing the data. This is the logo of La Sagra we have here in the wall. And here we have our living room, the kitchen, and all that. Okay? Now we try to go outside to the room. And the first thing that we will see is a very nice mountain. Don't know if you can see it.
Wow, yes, it's beautiful.
This is La Sagra. Now we have snow because last week was snowing, but the weather at this moment is very nice. And we expect tonight to do a good coverage of the event in 2012 DA14. First of all, we go to this small shelter where we have a telescope for tracking the objects we are discovering with the survey telescopes. This is one of them, 40 centimeters. And this small device we have here is what we have ready for tonight. This is a small telelenses of 200 millimeters attached to a video camera. We needed to put those strings there to try to focus the best for tonight's event. Last night we were trying, and it was getting nice images of some GPS and geosynchronized satellites that will move more or less at the same speed of tonight's 2012 DA14. So we are moving now outside of this shelter. Still a little bit snow here in the floor. Another shelter, we have another telescope here. The third. And the mountain there.
When did you build La Sagra Observatory?
When did you build? Okay, 2008. 5-6 years ago. Okay, I wanted to show you only one of the domes. Can see it now?
Yes.
Okay, we are walking in there. I go. Still walk. Here we have the other two survey telescopes. So you can see there the dome very far in the other side. And here we have one of the survey telescopes, and here the other. Precisely the camera granted by the Planetary Society and the telescope that discovered 2012 DA14 is precisely this one that you can see here. Okay? The shelter contains only two of the three telescopes. This is one, again. This is La Sagra mountain in the background. And this is the second telescope we have here in this shelter. Those telescopes, you can see that they're only very simple. So the CCD camera is attached in the focus. And here inside, we can find the mirror of the telescope. 45 centimeters.
That's great. And which
Okay.
which is the camera that the Planetary Society helped to provide?
Okay, we'll try to go because we have connected the laptop through the wire, but to the cable. But maybe you can see here in the top, in the focus of this telescope. Here is the camera.
Great.
And this is the telescope which is covered.
Excellent. Well, congratulations again on your discovery of that and so many other asteroids.
Okay, thank you very much. Thank you to the Planetary Society members, everybody who helped us to buy this camera and that provided this nice discovery.
And thank you. Gracias.
Gracias. Adiós.
Adios. So interesting facility they've got
It's
there.
fantastic.
Nice to see it. Sorry, it's webcam quality, but gives you a real nice idea. It was a beautiful day there, so they should have a great night of observing tonight.
And you have to be very diligent to see this thing. It's like 7 magnitude or something. It's very dim, right?
7 magnitude, so it's not naked eye, but it's just beyond a naked eye object. So binoculars or small telescopes can see it, but the challenge is it's moving across the sky much, much faster than a typical object. So I know in talking to Jaime, they've worked hard, and he mentioned setting up a different camera system just to try to track this moving so quickly.
How many moon diameters a minute?
About 2, at closest approach, about 2 moon diameters a minute across the sky. So
in astronomy, that's really fast.
yeah, you're designed to look at things that are not moving nearly
24
that
hours,
fast.
yeah.
So let's take some questions. Let's see, I lost one off the top here. Why didn't NASA use this encounter as a test mission for diverting near-Earth objects? Have they been testing theories in deep sea dives? No to the latter, but the former, I think it's a question of timing and money and budgets. They had 1 year to know it was coming, and that would not be nearly enough time to develop and mount a mission, much less the no less trivial getting a mission approved in terms of budget and plan. So it was too late. The other thing is this one's was coming so close to Earth that odds are no one would have had the courage, or you can argue foolishness, to try to change this one's orbit, because what if you screwed up and you knocked it the other direction?
This is the point that Rusty Schweikart makes.
Yeah.
He's an Apollo 9 astronaut. That it's very easy with these, or as far as we know, it could be easy enough to screw up and make the situation worse than it already might have been. And furthermore, with regard to this object, it was very well understood. So we knew it was going to miss. So if it's definitely going to miss, you don't spend too much energy on it. But you make a very good point. Could have tested this. So a lot of people around the world are involved in running tests to see what it would take to deflect an asteroid. And I referred to our colleagues in Scotland.
But at some point we could use more testing in space, but when you talk about doing that, you talk about a lot of money and taking away from other missions, and so it's something that we would love to see happen. Now it asks, was DA14 in range for Hubble, or was Hubble redirected to view it? The trick with Hubble, to my knowledge, was not redirected. I would think it would be nearly impossible because, again, Hubble's designed by its very nature to look really, really far away at objects that are not moving fast. So to track something moving this quickly, it would surprise me a lot if they were looking at it. There was an earlier question that I didn't get to, kind of the opposite end. Astronauts on the space station, did they have instruments or cameras that were going to look at it? One point is to remember that the space station is only 200 miles closer than the surface of the Earth is to this 17,200 miles away. So they get pretty much the same view that people on the surface do, although obviously without the interference of the atmosphere. I do not know if they're trying to do some capture, but it would be very challenging because it would be a dim object.
Well, I got to say, if I were an astronaut aboard the space station, and I applied, and I heard that this thing's going to go by, and I'm going to be swinging around the Earth every 90 minutes, I'm sure going to try to get a look at it. I mean, it's human nature. You'd want to try to see it. Everybody remember, the thing is as big as a building, a 5 or 6, 7-story building, which is big for a human when you're under it, but when it's 17,000 miles away, it is a very, very small object, and it doesn't reflect much light, so it's a tricky thing.
So if half the world's astronomers hadn't been watching 2012 DA14, might that have helped someone spotting what was coming from the other direction toward Russia? I doubt it, because first of all, you need to understand that the object that hit Russia, although very impressive, was 15 meters, much, much smaller surface area, very hard to see, very fast moving, very dim. So odds are we typically don't find those objects, which is a little worrisome, but on the other hand, they only do minor damage.
So about...
which is not a bummer if you're the one that had the minor damage.
3 or 4 times the width of this field of view.
So, but
17,000 miles away.
So
not
yeah,
easy to see.
Some object, yes, I suppose it's possible some telescopes are looking the wrong way, but I think mostly it's a factor of it's hard to find. All right,
what exactly can just regular people do, if anything, to help find these objects aside from donating, which I already have? Are there websites to help look over data or anything like that? There are in other programs I'm not aware. Oh, actually, that isn't true. One of our Shoemaker Neo grant winners, the Planetary Society grant winners, Bob Holmes in Illinois, has an education program that I don't think he's got for general public right now, but he's been doing great stuff besides in tracking and follow-up with his observatory in education. So he's making a lot of his data available, at least for students. So I think we may see that more in the future. But a lot of that's also done by automated computer routines in any case. There are other ways you can learn about these, or of course, there is the option, if you're really, really into it, of starting down the amateur astronomer route. But these are the amateur astronomers who have really dedicated themselves to not only learning their craft over time, but getting the really big instruments, building themselves observatories, doing robotic things.
Learning the sky.
So one can move that route and then make real. It is one of the, I would say, few areas in astronomy where amateurs make regular, significant, important contributions on a regular basis. But they are, again, a selected group of these amateurs. Okay, this relatively small asteroid has caused relatively superficial damage, presumably referring to the Russian bolide. How much bigger would it have to be to cause a catastrophe? So that one was about 15 meters. If you got up to 30 meters, maybe certainly to the size of 2012 DA14 to 45 meters, then you're talking catastrophe, unless you just happen to get lucky and you neither cause a tsunami or hit in a populated area.
And bear in mind that a little bigger, you could blow planes around, blow trains off the tracks, cars off the freeways. You could blow buildings, whole buildings over. I mean, it wouldn't have to be too much bigger.
Right.
Because these things are going so fast. That's the key. It's just the speed of it, you know, as you may know, the energy goes as the square of the speed times the speed. So when these things are going fast, and they're just even a little bit massive, it's like the one Tunguska and this 2012 DA14 was about 100 Hiroshimas. Is that right?
Yeah. So the Tunguska event, or if the 2012 DA14 had hit, the energy release would have been about 100 to 200 Hiroshima nuclear bombs.
200
so
bombs.
About 2 to 3 megaton, equivalent to a 2 to 3 megaton nuclear bomb. So big.
No radioactivity, but enormous pressure wave.
Yeah, right. And also shock and heat and all sorts of bad stuff.
And when the last of it makes its way to the ground at 25,000 miles an hour, it just punches big holes and destroys things.
Let's take another quick look at another Russian video of the bolide coming across.
A lot of dashboard cams. My goodness.
So we got dashboard cam, we're driving, and there it is. Wow. Well, you can see it starting to light up the sky. That is a serious fireball.
And then this is in stop motion, but it's less than a second that we're looking at there when it starts to go fireball, right? So two or three seconds?
Yeah, just very few seconds.
So it's not like you see it coming and you go take cover. I mean, it just happens in a moment.
And then, and then the shock wave travels down. Depends on where you are and how far away, obviously. Okay, let's take another question. You just spoke about types of asteroids. Does one type pose more risk to the world than others, assuming they're the same size? Yeah, there's the metal, the iron, nickel, and so the more we learn about what the objects are made of, which we'll also get a lot more information from this pass about 2012 DA14, that's going to be the ones that will have the potential to do more damage for a small size. Again, only about 4 or 5% of the asteroid population, but one of those caused Meteor crater.
If you have 100,000 objects that you don't know of, and 5% of them are, if I may, solid stainless steel, how many is that? That's 5,000. 5,000 asteroids that could, well, certainly destroy our economy worldwide, let alone kill a substantial fraction of the 7 billion people here. It's something to think about.
All right, another interesting comment and question. I just went out for lunch and no one knows about this. Do you think people purposely ignore or downplay this type of event because it shakes the core of their belief structures? I don't. I think they just don't get that it's a real threat. Or they just didn't hear about it. But mostly the people don't. It's hard to appreciate it on days other than today, where there are two of these things happening within 24 hours, that this is a real threat. It doesn't happen very often. And you don't need to lose sleep over it, but we do need to do something because it is going to hit. Things do hit
sooner or later.
Sooner or later. And that sooner could be tomorrow or it could be 10,000 years from now, but there will be a destructive impact. So. That's my thought.
Now, this is, by the way, there's a commercial company that wants to mine asteroids. Want to go out and find a solid metal asteroid and bring these exotic metals back to the Earth.
Which just happens to be the last question.
Yeah. But will they help us defend against asteroids? Yeah, it is presumed that the data that we would get from a Sentinel telescope, a telescope that would map all the asteroids that cross the Earth's orbit, or as many as we can get, those data would be then available to companies that wanted to mine it, and then those companies would develop technologies that would take us out to the asteroids in routine fashion. But with that said, this is generally not a government job. This is generally a government job, not a private job. You know, private companies aren't so motivated to go out there, but space agencies are. And this is another thing for you voters and taxpayers around the world. This is another important use of our intellect and treasure.
Okay, how are we doing? Let's see, why don't we... Well, it doesn't really show much more. I was just checking out what else we got on there. You can go ahead and pop that up, but it's just a previous image from a little while ago from Samford Valley Observatory in Brisbane, Australia. So inside, we can see that the asteroid looks like a circle. Wait, no, the asteroid's probably the object inside the circle. That's my guess. Yeah. Okay, why don't, well, I'm trying to figure out what else we got going. How are we doing time-wise? Okay, we will keep going for about another 5 minutes.
And I just got to note, Chris Lewicki, who is a guy who is working on planetary resources. This is the guy who wants to mine asteroids. He'll be on our radio show next week, Planetary Radio. So tune in. I listen by podcast.
You can listen by podcast, or you can listen via Sirius XM, or you can listen online at planetary.org. A reminder, before I forget, to remind everyone, we do have resources, both on 2012 DA14 and on the Russian Fireball on our website, planetary.org. You can check, find links from the homepage to get more information about both these exciting, amazing things going on in the community. Okay, I've got, there's a question, is there a BOINC network I can donate computer time to for simulations? I'm not familiar with that. Hang on just a moment. What?
There's asteroids at home.
There is asteroids at home. There is something going on.
I wonder if, sorry.
Sorry.
No, please. I'd heard of it, but I didn't know its status.
So, look up asteroids at home. We don't have a lot of information here, but I'm sure it's on that, what do you call it?
The web, the kids are all using it.
Oh, the web, the internet, the kids are all using. All right, we will finish up shortly. Why don't we, do you have some some reflections? Oh, you're just finding information right now.
I was just looking at asteroids at home, and it's got a lot of words. So, and the user of the day. So, it's an exciting day. And what a galactic or cosmic coincidence that we last year found 2012 DA14, an asteroid that would, I guess, be a city killer.
Yeah.
And then the same period, 24-hour period, there was a bolide, or an airborne daytime meteor in Russia that blew out a bunch of windows and injured a bunch of people. Really is an extraordinary day, and we hope that humankind will embrace this and get to work on surveying the sky so we know where these things are, so that humans just in the next few years can come up with systems and ways to deflect one with our name on it. You know, when I was a kid, there was no good theory as to what happened to the ancient dinosaurs. My second grade teacher told us that they had small brains, so the rabbits took all their food. And even she knew that that was just she's reading from a book that she had been given. She knew that that was just an unsatisfactory theory. But in my lifetime, we discovered the crater off Chicxulub, Mexico, which is almost certainly where an impact occurred that took out most, if not all, of the ancient dinosaurs by creating a worldwide fireball. The ejecta, the circle of the ejecta was bigger than the diameter of the Earth, and so it just set the world on fire. And this could happen again. And today is an historic day. 15th of February 2013 is when humankind got a serious wake-up call. Let me say lastly, thanks for your support, members. Thanks for helping us out at the Planetary Society. It was through your funding that Jaime Nomen and his colleagues in Sagra, Spain were able to find this object. Thank you very much.
Yes, thank you. And remember, go to planetary.org for more information. You can check us out on Twitter at Explore Planets, or The Science Guy, or Random Space Fact, or E. Lakdawala, who will be blogging things.
She's been tweeting up a storm, Emily has.
Also Facebook, the Planetary Society. Check out more information.
Planetary Radio.
Planetary Radio at planetary.org/radio. With host Matt Kaplan, who's hiding off to the side. I can practically slap him. Right?
There's his hand.
Yeah.
Yes. So
thank you all for joining us. This has been an exciting day, and stay tuned for more information from the Planetary Society. Thank you, and good night.